Hello everyone, my name is Radhika. Welcome back to another episode of Teal Bites. Today we're pleased to host Mr. Akilur Rahman, Chief Technology Officer and Market Innovation Lead at Hitachi Energy India. Akhilur leads technology, digitalization, and innovation towards the market and customers in India and supports market innovation in South Asia. He has more than 3 decades of experience in research, R&D, technology management, engineering, consulting business, and product development in power, automation, and digital technologies. In his current role, Akilur has been leading core automation and digital technologies for power, energy, and asset performance management in utilities, industries, infrastructure, and the transport sectors. He has also been a thought leader, speaker, and panelist at various international and national conferences. Akilur, a very warm welcome, and it's great to have you on Teal Bites today.
Thank you, Radhika. Very glad to be here and also pleased to share my knowledge and information about the energy transition.
Thanks, Akilur. The pleasure is ours to have you today. So, Akilur, jumping right in, today I would like to get your insights on, with the growing emphasis on sustainability, how is your team driving innovation at Hitachi Energy to accelerate renewable energy adoption and integration? Your views, please, Akilur.
Yeah, sure. So before I get into the details, so just our company, Hitachi Energy, it has the legacy of more than 140 years, always innovating, and
Right.
especially in the electric energy domain. And so we are seeing that the sustainability, the target, carbon neutral target, and also countries' target for renewable energy by 2030, which is 500 gigawatts, is a very, very aggressive target. And a lot of work happening there, planning also, I think definitely we can meet. So that actually opens up a huge kind of opportunity for innovation for us, for also the owners, operators, developers of this system.
Right.
Just to tell you, to achieve this 500 gigawatts of renewable energy, fossil-free energy by 2030, I think we need not only the renewable energy generation, but also how you evacuate the energy from the renewable plants sources to the delivery. It can be few thousand kilometers away. So that also gives opportunity for us to use our technologies. So
Right.
coming to innovation, so we are for this energy transition, there are three important areas. One is the power electronics, which is
Okay.
basically using power electronics for high voltage DC transmission with compensating the power, reactive power, static compensators. So second area is digitalization on top of the automation, the power automation. And the
Right.
third area is also having the sustainable products which can reduce the carbon footprint very much drastically. So it's not about just addressing the renewable energy delivering, but also making the whole process also CO2 less of CO2 and carbon footprint. Yeah.
Absolutely, and that is very much the need of the hour as well. Sustainability is. So, can you just share some examples on, how you go about in each of these areas that you mentioned?
Yeah. So coming to power electronics, which is basically the high voltage direct current transmission system. So it has been there since 60s, 70s. It was used for bulk power transmission in India. Also, it was there.
Okay.
We were the first one in India to set up and install and commission the first HVDC system in India in
Okay.
89, 90. And there onwards, we have installed many systems. For example, transferring power from northeast hydroelectric power northeast to center of the country, north central, which is Agra. So it's about 100,700 kilometers away. And then having also this multi-terminal HVDC,
Okay.
which is a first in the world. I think the HVDC brings in very high efficiency of transmission, reducing the losses, reducing the voltage drop, and also at the same time taking less footprint. So that's the example. And in future, also we are going to have a lot of HVDC lines coming from, let's say, Leh Ladakh to Kaithal, for example. This is what is being planned by the government, that tens of gigawatts of renewable energy which can be set up in Leh Ladakh area, which can be evacuated. So evacuating that much of power, transmitting that power in transmission lines, which can take less footprint of the corridor, transmission corridor. So that's important. And also this power electronics gives flexibility in terms of controlling the power. Uh, both way. It can be a reverse power flow. For example, Raigad, Pugalur, which is Raigad in the center of the country, Pugalur in the south. So this line is used for transferring the renewable energy from south to center of the country. At the same time, when the south is having power shortage, it can also feed power from the center of the country to the south. So in future, it is also going to be from sea, windmills in the sea, and then that power has to be transferred to the shore. And that can be also using high voltage AC or high voltage DC. And then here, the power semiconductor, they are used. They are very special technology here. You can just imagine that our TV, they use power semiconductor. But this type of HVDC system, they use semiconductors which can handle almost 25 million times more power than a TV. So you can imagine, and then that also has to be controlled in millisecond. So this is the technology what we are bringing in, and in future it is going to be very crucial for the country. And in fact, this week we also got an order for evacuating power from Kutch to Nagpur. So more than 1,000 kilometers. So using this HVDC, high voltage DC technology with power electronics. Yeah.
Okay. And how do you take care of the sustainability bit?
Yeah. So we have for this kind of power transmission, power systems, we have different type of equipment, technology equipment like transformer, for example, which transforms the voltage from lower voltage to higher voltage for transformer. We also have switch gear, which is circuit breaker, it's called. It's like at home you have the switches, the light switches. And but this is also switch, but it handles powers million times more power than the household power. Yeah.
Right. Yeah.
So it's like almost 1 billion times power it handles than a switch. And this uses special insulating material, insulating media, gas, because when the switching happens, you can see the spark which happens during switching, and you can imagine 1 billion times more power, how much of energy and temperature it increases the temperature by 20,000 centigrade, which is 5 times more than the temperature of the sun's surface. So this insulating media is sulfur hexafluoride gas, which is used, but it is very, very carbon intensive. So we have come up with a new circuit breaker with SF6 free. We are using another material. So one system, one substation, gas insulated substation with SF6 gas, sulfur hexafluoride gas, can actually replace the amount of carbon dioxide which is emitted by almost 100 jumbo jets from New York to Paris. You can imagine, just one system. And there are thousands of such systems which are in use, which are going to be used in the renewable energy transition, and also transmitting to the load centers 1,000 kilometers away. So this is the example of how we are also, in our products, we are trying to reduce the carbon footprint. Maybe another one, it's about digitalization. So in our system, I talked about how the millisecond counts. So basically, you can imagine, let's say Leh Ladakh to Kanyakumari, if the power has to flow from Leh Ladakh to Kanyakumari, it's just 14 millisecond. It travels, the electricity, the electron travels in that speed. So we have automation, which is basically taking care of the every millisecond coming, data coming from different sensors, different equipment, different processes, we have automation, but on top of that, we are also doing digitalization in terms of how this, let's say, the transmission corridor can also be monitored for, let's say, because it runs through the forest, it runs through the mountains, and
That's what
so
I was just
using
going to
the
ask,
satellite.
like, how does it run through, like, through underground cables and,
No, it's over it. Over
it's
it, we can't
overhead.
have, let's say, we can't have underground cable 1,000 kilometers running through forest, rivers, mountains. So it is over it. But
Overhead cable.
uh, but we want to minimize also the cutting of the trees, because trees
Correct.
will
Yeah.
create short circuit fault in this. So,
Yeah.
but you should not overcut it, because that you are destroying the green corridor. So we are using satellite imagery, drone, and ensuring that the green forest cutting is done only to the optimum level, not doing it more, and
Right.
also real time monitoring of how the tree, the forestation, they grow, and before they actually create any problem, so you can cut. So this is a sort of digital application using satellite imagery and drone. And similarly, we also have how to predict the, let's say, the renewable energy, let's say from Leh Ladakh or from the deserts of Rajasthan, and in millisecond, how in second, in minutes, how you can predict that. So we also have the AI based, artificial intelligence based
Okay.
forecasting software. So these are examples. Also asset performance management before the asset fails or malfunctions, how you can predict, so that you can reduce, prevent any blackout, any tripping of the circuit. So these are the examples of digitalization. So three areas: power electronics, digitalization, and sustainable products. I think these are the future where we are innovating greatly with all these applications, both domain and digital side. Thank you.
Great. Thank you so much, Akilur. That was very, very interesting to hear. Thank you for sharing your very insightful perspective on, how Hitachi Energy is driving innovation in renewable energy. You know, and also how it's impacting and shaping in a positive way for a sustainable future, right?
Yeah,
So,
because energy touches everybody, starting from individual
yes.
to community, society, industry, infrastructure. So everybody. So I think this is definitely a big sort of vision for us, for our country also, to be having the renewable energy by 2030, half of the electric energy, and also carbon neutral by 2070.
Yes,
Thank you.
absolutely. Thank you so much, Akilur. Thank you so much once again for being a part of Teal Bites. I look forward to connecting with you again on, many such insights from you and on, many other such topics. So thank you so much, Akilur. Have a great
Thank you,
day.
Radhika. It was my pleasure, and surely we'll connect again, because these topics are evolving. There are a lot of things, innovation, also involvement of everybody required to achieve this. Thank you.
Right. Absolutely. Thank you. Thank you so much.